There is a spoiler alert that I am in costume because we're talking about the start of certification. So I may not be quite back on the first street, or I may not look like a worker on the Hoover Dam or the Erie Canal, but the fish tie should give it away. But I do want to say thank you, Luke, because it is one of the inspirations. The Erie Canal was actually one of the articles that I remembered from Luke Snell. One of the reasons I read Concrete International was to flip it to the very back page and to look at it. And the Erie Canal was one of my favorite articles. So thank you, Ann, for presenting on that. That was fantastic. Again, certification. Why would I pick a boring topic? Well, it turns out I'm a concrete producer in Northwest Arkansas. And are there any other producers in the room? Okay, there's one or two. It is the bane of a concrete producer is badly tested concrete. I've said in a meeting in the middle of summertime as to why would this concrete be quote unquote bad? Well, it's bad testing. If there's not a minimum standard for testing, it's all going to be bad. Okay, so we're going to move on to if there is bad testing, but how far back does testing start? And so it got me to thinking, well, how does this fit in history? So I've got a couple reference timelines for where do we start? And in 3000 BC, we've got Egyptian pyramids. I think that may be covered a little bit more in the next presentation. Bedouin structures used some hydraulic lime back in 700 BC. The Greeks, 600 BC, the Parthenon, some of those. Romans in 300 BC, you hear a lot about Roman concrete, even though they may not have been the first. But somewhere after the Romans in about 400 AD, 1500 AD, we kind of have the Dark Ages, we step back. There's not a lot of concrete development. So we jump ahead to 1759, John Smeaton. In Britain, he developed the Eddystone Lighthouse. That's where the Portland cement was used. Where hydraulic cement was used. He came up with a new formula because in 1824, Joseph Aspdin took over Edgar Dobbs' expired patent and was kind of coined the inventor of Portland cement. Now there's Louis Vicat over in France in 1817 that kind of would dispute about who actually developed this and simultaneous tracks, even though they weren't colluding. Just for reference, we got to go back. The Erie Canal, that was in the 1820s. So that fits in here as well. I want to show that in 1836, that's not long after these guys are looking at the Portland cement as we would kind of coin it today with the chemical composition. The first tensile and compressive tests were occurring in Germany. 1836 is a long time ago. In reading through the ACI literature, the best I could determine was in the 1920s for the compressive testing was, that's when I read that in the 1920s, compressive testing was mentioned for ACI. And I found it very interesting that they were debating in 1923, 6x12s cylinders versus other sizes. I thought this was kind of a unique thing about 4x8 cylinders in the 2000s. No, this was back in the 1920s. Also, very interesting in the 1926 article, the temperature of cylinders were studied. And again, I talked about bad testing. Most of it generates around the curing and the initial cure temperature in the field. And that's been around since 1926. So this is obviously not a new debate. We're approaching 100 years of celebrating the temperature and the initial curing. That was interesting. So rolling back into 1877, the German Cement Manufacturers Association had the first standard for Portland cement. Joe, have you read that one?
Yes, I have.
Okay, I figured that would be on your nighttime reading bedside list, but you hadn't even suggested it to me to read yet. But 1897, Rene Ferret develops a relationship between the strength and the volume of cement, water, and air in concrete. Basically, the volumetric, I learned about that in geotechnical engineering as well. 1898, there were 90 different formulas, but by 1900, basic testing and manufacturing methods became standardized to reduce that number. The interesting one, Sears Roebuck in 1897. You could buy a 50-gallon drum of cement for $3.40. So this falls back in line because we were just talking about the tombs in New Orleans, so that you could buy your barrel of cement for $3.40 to create your tombs. That was all about that 1897, 1898 range. Stepping back just a smidge, 1868 was when Portland cement was first imported. And it was, again, the first date, 1865, documentation is a little fuzzy. I talked to people, we had the presentation yesterday in the ACI mini session. It was, what was the building? The gentleman who talked about the building? I'm sorry. Yes, the Walters Museum Annex. And he was talking about early records and being bought out and losing records throughout the years. It is hard to contain records. And in 1865 was back before anybody was born, I hope. So 1873, we had the first patent for a chemical admixture for a calcium chloride accelerator. I thought that was another fun little fact. So we've kind of established 1902, 1897, we had a lot of development. So in 1902, the Association of American Portland Cement Manufacturers is founded. Renamed in 1916 as the PCA. I'm sorry, I didn't include the current name change as well. Again, for reference, 1891, we have the first concrete street in Bellefontaine. Bellefontaine. Now, about this time that the PCA is in 1916, I saw pre-1914 that the concrete mix designs for all those manufacturers out there was 1 shovel cement, 2 shovels sand, and 3 coarse aggregate shovels. That was your concrete mix design recipe, 1, 2, 3. The problem with that is that your consistency of shovel sizes, Ann didn't bring her shovel, so I'm curious to see on the Erie Canal, what size shovel did they use? But a 1, 2, 3 was approximate. But using the 1, 2, 3 in 1903, you constructed a 16-story building in in Cincinnati, the Ingalls building. So the first concrete high-rise was constructed using a 1, 2, 3. That's an interesting, we do have compressive testing at this time because that was 1836. 1904, the ASTM published C01, the first standard, and it was because the railroad company needed standards for the railroad industry for steel, and that was C01. 1904, Portland cement was throughout the United States, is featured in the World's Fair in St. Louis. Again, the pretty little picture. 1905, the National Association of Cement Users, NACU, everybody remembers NACU. Oh, but NACU was later renamed in 1913 as the American Concrete Institute. 1909, kind of within these dates, Thomas Edison patented the rotary kiln for cement manufacturers. 1913, there was a motorized load of ready mix delivered to a project. 1927, you have pumping of concrete. So Jacob, in 1930s, when you were building the Hoover Dam, there was concrete being pumped. Just the bucket method, I think, was much more efficient for the Hoover Dam. I don't know that they'd perfected any of the pumping. I think the patent came later in the mid-30s. Yeah, 9-inch aggregate. That would be a big pipe. I mean, obviously, you need a big concrete cylinder. So 1929 is the ACI journal was established. So quick timeline checklist. We've got ACI, ASTM created, Portland cement, compressive strength testing. I wanted to ask, when are you looking at the slump in the air entrainment test? Well, it turns out ASTM CO9 for concrete was established in 1914. Now, did we have kind of smooth sailing from 1914 till when we're talking about in the future, again, fish tie? Not quite, because a recent survey said that before 1930, that 20 years prior, they made better concrete. Wait, I think we've heard this argument just recently that we made better concrete in the early 2000s or before 1L or before. It seems like 20 years ago is always the window of past, previous, better concrete. Yeah, the older I get, the better I was, exactly. So quick update on this slide is in 1936, ACI and ASTM divided the responsibilities of who kind of got what. ASTM became more testing, ACI more concrete. 1931, AASHTO was founded. And in 1938, the CFR Title 23 for highways required concrete to be tested prior to use. So that's an important date, 1938. It requires testing, but what about the testers? Well, again, we talked about bad testing. There was not a national certification at this point. You just required testing. There was not a standard. And in 1973, the Skyline Plaza in Bailey's Crossroads, Virginia, fell. They had a form failure. The forms were being removed and the concrete failed. 14 died and 35 were injured. So that kind of leads into, well, when slump in air? Duff Abrams, in 1918 to 1922, developed the slump test. 1918, he had a standard method for optimum slump, was the paper that he wrote, and combined with the water cement ratio and a way to sort of quote unquote measure it. Kind of explains the slump test has been around since the 1920s. What about your air meter? It's been around since 1946, previously called the Klein air meter. And I found the fun little article by W.H. Klein and Stanton Walker in the ACI Journal in 1946. And here's a picture of the apparatus that was designed. Because you have to remember that in the late 30s, early 40s, Powers was also studying the air entrainment durability of concrete. And so if you have the air bubble sizes, you have to find a way to measure them. So the pressure method was developed here in the 46, because prior to that, the early 40s, it was the gravimetric method, meaning you had to know the specific gravity volumes exactly so you could calculate the air entrainment. Interesting about the air meter here is that the paper cited the reference at the central lab at the Pennsylvania Cement Corporation in Bath, Pennsylvania, and it was also hinted towards development at the NRMCA. L.C. Hawks, D.L. Bloom were kind of some of the original people that at the central lab that helped develop this method. Another interesting thing on the paper by Mr. Klein is that they published the article and said, we release all rights and everything else. Please go develop this test further, because it appears that this is a good method for calibrating the gravimetric or calculating method. And so they released all rights and said, go test, please. Do not wait on us for further development. So the rollometer was also 1946. Interesting out of this paper, as if anybody's ever run the rollometer, in 1946, they developed a paper that said we can go from 0.35 cubic feet to 0.22 cubic feet. Thank you to whoever did that paper. So prior to certification, there was a certification in every state. I know Houston chapter and the ARMCA, the Arkansas Ready Mix, everybody was testing different things and had their own certifications per state. So nationally in 1978, they came up with a national certification. There was a reference to barbers had certifications nationally, so why didn't concrete? In 1980, the ACI E902, the EAC, the Education Activities Committee, came up and they came up with 6 different items that were easily agreed upon. The problem is, like item number 4, it took 2 years to resolve that item. How do you certify? What's the education proponent, or do you just give the test? And they decided, well, we're just going to have a basic bare minimum test and then leave the certification up to other people. Of course, any organization is always about funding. Apparently in the 1970s, ACI was floating, but just barely, and they were worried that the certification process would put them under. Again, 1983 was the actual first test. Then I found a certification ACI update. 1983 was the first test, and by 1985, they were actually making money. So it turned out to be an okay thing for them. 1985, oh, it also helps that it was required by technicians to be field certified. So is the roller meter relevant, and should there be a field 2 test? But this was in 1946, we had both methods. 1983 certification happened. This is a debate that actually, I believe, happened just 6 months ago. It was, is the roller meter still a relevant test? And 610 meets at the exact same time. If this is interesting, be sure and go to 610 next time. But this was actually a test that was just debated again if the roller meter is an additional test. So temperature is one I didn't have a slide on, but it was an optional test until the late 80s and required somewhere in the late 80s and 90s, it became a required test for the field certification. Another local reference, 1983, Fort McHenry Tunnel was developed. So most of this tunnel was built before there was a national certification. Makes you wonder, did they test it according to standards? I do want to mention field certification beyond. Certification is a bare minimum that you can pass a test. CTAC, a very interesting program, is saying, are we using this certification in a relevant manner? Can our testers being diligent in testing? And what is the future? Are we going to ever add another test? Is there going to be non-destructive testing? Is it going to be rheology, super air meters? And last but not least, this is concentrated more on the ACI field level 1 testing, but ACI has over 30 programs. This is a copy of their page. Each of these, you can delve down into it. These are the different topics that have different tests involved. And close to 1 million people have been now certified through ACI. And it is, I believe, over 50,000 people a year take tests through ACI certification programs. So when you're waiting on that test to come back, just remember there's 50,000 people this year that are being tested. It is a large department, but it is not huge. Alrighty, thank you.